Okay, good afternoon, everyone. Folks, just to give you a recording notice that this class is being recorded. So far, what we have done, we have defined the random variable. Now, in the random variable, we have studied the two classification. One was the discrete random variable, and the other classification was the continuous random variable. Now, we also studied some of the properties. How do we find the mean? How do we find the standard deviations of in general, and for the discrete random variable particularly. Now, today we are going to study some distributions. By that, I mean to say, if you remember the profiles that we were developing with our examples only, these were some kinds of the profile that we were studying. So we have the histograms available for discrete random variable and for the continuous random variable. It was something like this that we discussed last time, right? Now, based on this graphical trend and the variable, either this is the discrete variable or the continuous variables, we have some classification of the distributions. Today, we are going to start with the distribution of the discrete random variables. Now, the first distribution that we need to start today is the uniform distribution. Now, what is the uniform distribution? The uniform distribution is defined as a random variable has uniform distribution if each of the n values in its range. Now, the range can be defined as, let's say, from x1, x2, x up to x of n. Okay, has equal, this is each, has equal probability So a uniform distribution defined as a random variable has a uniform distribution if each of the n values in its range, say x1, x2 up to x of n, has equal probability. So here this word is the most important in the equal probability. Okay. Mathematically, how do we denote this? This is written as the p of x, and the probability value is equals to 1 over n. We also write it as capital U, which is for the uniform distribution. We have the x, then we have the semicolon, capital N is equals to 1 over n. So in uniform distribution, this n is basically called as the parameter of distribution. Okay. So for those of you who are just joining us, we started with our uniform distribution. We defined the uniform distribution, and we have defined the mathematical relationships for this distribution. Now we will take an example. I'm going to the next slide now. We'll take an example here. So let's do an example. Now, for example, when a die is tossed, each element of the sample space now for the die, you know that this is the six-sided, so I can say the sample space could be 1, 2, 3, 4, 5, and 6. Okay, this will be the sample space when you toss a die. Has equal probability of 1 by 6. So that means to say, if you toss a die, maybe you will get 1, maybe you can get 2, maybe you can get 3, maybe you can get 4, you can get 5 or 6. So these are all the equal probability, or there are equal chances that you can get that number. So the probability will be 1 over 6. Or I can write it down as u x of 6 is equals to 1 over 6. Okay. So again, this is 6 is my capital N, which indicates the number of values of random variable x, or we can say this is the element of sample space. Okay. Now, how we draw this uniform distribution? So we have the same graph as we were discussing before. We have the values of x here, and we have the probability. Now, in terms of the uniform distribution, we will have it something u of x of 6. Okay. So for example, this is my 1. I'm doing it for this example that we did for the die. We have 2, we have 3, we have 4, 5, and 6. 4, 5, and 6. Now we know that it is equal probability. For example, if this is my 0, and for example, this is my 1 by 6 up to this point. So everything, it will go a straight line from here, because each and every element here, 2, 3, 4, 5, and the 6, they have the equal probability. So the graph will be something like this. Clear? I'm going on to the next slide now. Now, for the uniform distribution, we are going to define the relationships for mean and the variance. If X is a discrete uniform random variable on consecutive integers, for example, the integers could be a plus 1 because they are consecutive, a plus 2, and up to the point b, where we need to make sure that our a value is either less than or equal to b. The mean is the mean of X is defined as mu is equals to, this is also called the expected value as we are studying before. So the formula that we use is the b plus a over 2. That's the formula for the mean value. Now for the variance, in terms of the variance, we have the formula is the sigma square is equals to b minus a plus 1 whole square minus 1 over 12. That's the formula for your variance. And if you want to take the standard deviation, you just take the square root of this sigma square. This will give you the standard deviation. Okay. I'm going on the next slide now. Am I going too fast? Okay. Now let's do an example here which will elaborate more how we apply these uniform distribution. So let a random variable X denote the number of of 24 computers that are in use in an office. Okay. Now, what is the variance? What is the variance of X? Of X with a range from 0 to 24. 0 means we don't have any computers. 24 means we have 24 computers. So we just look at the formula. So the mean is the b plus a over 2. Okay. Now in this given problem, our a is 0. It is starting from 0, and the b is the 24. You can easily calculate your mean value, which will be 24 plus 0 over 2. That is 12. Now, in terms of variance, we know the formula for the variance as well. So it is the b minus a plus 1 whole square minus 1 over 12. Now, when you plug in the values and solve it, it will be 24 minus 0 plus 1 minus 1 over 12. So you get the answer of 52. Okay. And in case you want to find out the standard deviation, just take the square root of 52 value. So it will turns out to be 7.211. Okay. Now from your textbook, Douglas and George, which is available on D2L, you will go to page 71 and you need to work on the example 14 and 15. This will give you more idea how do you apply this uniform distribution. Okay. Now, the second type that we are looking to study is the binomial distribution. This is again for the discrete random variable. Now, in order to define this binomial distribution, we need to know something which is called as the Bernoulli Trial. How do we define the Bernoulli Trial? It is an experiment whose outcome is random and can be either of two possible outcomes. Okay, so the Bernoulli trial is basically, it is an experiment whose outcome is random and can be either of two possible outcome. Now here the two word is important here. So in the binomial distribution, we will have only two outcomes. Now, as an example, such as it could be the failure. When we are talking about the failure, the other could be the success. Failure and success. Okay, it could be good or bad, two outcomes only, or it could be occurrence and the non-occurrence. Okay, so the Bernoulli trial is when we have the two possible outcomes such as the failure, success, good and bad, occurrence or the non-occurrence. Now there are three conditions. I'm going on the next slide now. What are those? The first is A Bernoulli trial is repeated n times. Okay, and the second is the probability of occurrence P remains constant. Okay, the probability of the occurrence P remains constant from trial to trial. Trial to trial. Now the third is the repeated trial are independent then the probability of X occurrence at total n trials can be described by the PMF. Now you must be very clear why I'm using the word PMF here, because I'm talking about the discrete random variable. When we will go to the continuous random variable, I will talk about the probability density function instead of the probability mass function here of a binomial distribution. Okay, I'm going to the next slide now. Now mathematically we denote it as the probability of X this is a comma, and then you have n/p. This is equals to n of X p power X into 1 minus p power n minus X. Okay, I will come back to this. What is this? Now there is another way to denote this probability for binomial distribution. We write it as, you can write this, or you can also write down as the B X semicolon n comma p. Okay, now what is this here? this thing you have done in your undergraduate statistic courses, I believe. This is what we called as the combinatorial notation. Okay, NX. So this is the combinatorial notation. This is same as we are doing combination problems in your undergraduate studies. Okay. Now, how do we solve this combinatorial notation? So you have, if you have n and x for two variable, n and x here, you solve it using n factorial and divided by the x factorial n minus x whole factorial. That's what the formula is for this. Now this symbol is what we called as the factorial notation. Okay, just to give you an example, if you have now this is a general formula. If n factorial is the n into n minus 1 multiplied by n minus 2 until you reach your 1 value. So if I have let's say 3 factorial, we will have 3 times 2 times 1, you get 6. 1 factorial is always 1. Okay, and the 0 factorial is 1 as well. Now just for your revision, I'm going to write down some rules on the next slide. These are some of the rules for solving them. So if you have n with the 0, this will be equivalent to n with the n, and the answer turns out to be 1 always, 0.01. If you have n with the 1, this is equals to n. If you have n and 2, for example, then you get n into n minus 1 over 2. Okay. If you have n and m, this is also equivalent to taking the n and n minus m. Okay. Now in the binomial distribution, the formulas for the mean are, we have the mean formula mu, which is also is equal to expected value, which is e of x. Okay, this is equivalence to n times p. Whereas our sigma square is equivalence to n of p into 1 minus p. Okay. Now here you need to note down the p is the probability of occurrence. Now there is another notation that we use some of the time, the q. Q is the probability of, this is probability of non-occurrence. Okay, non-occurrence. Or I can say that q is basically is equals to 1 minus p. So why I'm telling you this? Because this formula sometimes is also written as sigma x square is equals to n of p into q. Okay. Just to give you some more examples for the binomial distribution, when we toss a coin, what do you get? You will get the two possibilities. Either it could be the head or it could be the tail. This is what we called as the binomial distribution. This will follow the binomial distribution. Binomial distribution. Similarly, in the production environment or the manufacturing, in manufacturing, you could have two possibilities of the product. Either it could be a defective product or it could be a non-defective product. Because there are two possibilities, it also follows the binomial distribution. Okay. Now let's do an example. The probability that a certain computer will survive a shock test is 0.7. So there are 70% chances that a computer can survive a shock test. Now what is our task here? Find the probability that exactly 2 out of the next 4 tested computers can survive. Okay. So what is our example here? The probability that a certain computer will survive a shock test is 0.7. Find the probability that exactly 2 out of the next 4 tested computers can survive. Now I need to go to the next slide. Okay. So what is the solution here for this example? Solution. Now we know that the computer, according to the statement he's given us, there could be two possibilities for this. Either it could survive the shock test, or it would not survive the shock test. Okay, so this is how we know that this is the binomial distribution. Now if you go back to the question, we were saying that the probability here, this probability is 0.7. So what is my p-value here? My p-value is 0.7. Okay. Now n is the in the formula, basically, n is the number of trials. Number of trials. And your x is basically the number of success. Now, the number of trials from this question statement is saying that is looking to have the 4 tested. So this is my value of the n. So what is my n here? This is my n and it is 4. Now the number of success, he is saying that exactly 2 computers. Okay. So this will be 2 here. Now we just use the formula that we were doing before, that the b of 2, 4, 0, 7 is equals to 4 of 0, sorry, 4 of 2, 4, just leave this, 4 of 2 times 0, 7 square times 1 minus 0.7. That's simply the formula that I just wrote it down in the previous slide. Okay. When you solve it, you will get your answer as the 0.2, 0.265. This is a notation. We can also write it down. P of x of 2, 4, given that 0.7. Both of them are the same. They are not different. Okay. Now, I'm going to go on to the next slide. Now, another question within this one could be, what is the probability? What is the probability that at most 2 computers survive the test? Okay. Now what he's asking here, what is the probability that at most 2 computers will survive here? By the at most, it means to say, this word is showing you, he's asking us to find the maximum, so that the maximum of the 2 computers could survive. So I can write down my formula for the binomial distribution as x is less than or equal to 2 of 4, and this is the probability 0.70 or 0.7. Now how do you solve this? So as you can see here, it is asking up to 2 and less than that. So I will start my formula with 2, the same formula as we were doing before. Probability of 2, 4, 0.7 plus the, and I will start from 2 and I will go up to the 0 value. So this will be probability of 1, semicolon, 4, 0.7 plus the probability of 0, semicolon, 4, 0.7. Okay. Now we need to just solve them one by one and need to find the answer. So once you find the answer for this one, and this one using the same formula as we were discussing before, you will get the answer of 0.3483. Okay. Now this is the answer, of course. Now this is one of the way that you can solve this problem of the binomial distribution. Another way is that we can use some standardized table, and I will show you now how we do that. So this was the one way. The other way could be, the other way to solve it is to use the tables. Now if you look on this binomial distribution here, this is the same as finding out the value of f of 2, which was the cumulative distribution function, CDF. And how do we do that? I will just show you the tables now. Okay, folks, these are the tables for the binomial distribution. I hope it is clear to everyone. Can anyone of you please confirm me if this is okay? Okay, good. Thank you, Sean. Now, first you must understand how we read these tables, and then I will take you to how to apply them. Okay. Okay, now these values here, all these values okay, all these values here, these are the probabilities values. Okay, somehow I cannot use my pen over this. Anyhow, so these are my probability values. Now on the left hand side, this column is for your n values. This column is for your n values. Okay, so this is n is 2, n is 3, 4, 5, and up to so on. Now next column to the n is the r column here. This is my 0, 1, 2, 0, 1, 2, 3. Now if you recall here, this r can be maximum up to the value of the n. So you could ask me why we don't have the r values at 3. That's because the n is for 2. The maximum r can be the value of n. It cannot exceed these values. The maximum value cannot exceed the value of your n. Otherwise, you will not be able to solve that combinatorial formula. Okay. Now, all these values inside, these are the probabilities values. For example, at 0.20 here, at 0.20, I have the value of 0.640 corresponding to r is equal to 0. Now, how we use this table? I'm just giving an example, then I will come back to our example that we were doing before. For example, if you have the probability of 0.01, so you know that this is the column that you need to choose. And you have, you know that your n value is 3. So this is my n value 3 here. And you know your r value is, let's say, 2. So your probability here will be 0. This is the value that we are interested in, right? This is how you use this table. Now coming back to our problem, see that our probability value here is 0.7 as it was given in the statement here. Okay, so our p value is 0.7 here. Okay, our p value is 0.7 and the n value is 4, and we are interested to find the x value at 2 or the r value. So we'll go back to our table. So this is the 0.7 here, which I'm interested to find out. Okay, and now I know that the n value is 4 here. This is my n value 4, and this is my 0.7 p-value. Now in the r value or the x value, this is 2. So this is the 2 here. So I come straight from here and I can see that what is my values here. It is the 0.265. Now one thing you need to keep in mind, this table is indicating the probability value itself. It is not giving us the CDF values. By that I mean to say, if you are interested to find out the value at r is equal to 2 or x is equal to 2, you need to add up all the previous values. So you will say that 0.008 plus 0.076 plus 0.265. The answer will be your combination probability. So it will be the sum of the probabilities. Okay. Now this is the one kind of the table. Now, another kind is the sum of the table. Now both of them, there is a slight difference in them. If you look on this table, table is based on the sum of the binomial probabilities. By that I mean to say, if for example, we were adding up the 0.08 and 0.76 and 0.65. But if I have the probabilities value seen in this table, that will be my direct answer. So let's solve this table as well. So P is 0.70 as in my problem. The value of the N is the 4. This is my 4 here. And corresponding to 2, I figure out that my probability value is 0.3483. Now this is the CDF value that I am interested in. If you will add up the previous value of these one, that will be wrong. Why? Because this value of 0.3483 is already a CDF value. However, if you are using the table, this table, I will provide you both tables. If you are using this table, you need to add up your values. 0.008, 0.076 and 0.265. These need to be added in order to find out the value or the CDF value at r is equal to 2. Okay. Now we will go back to slides here. Okay. Now, what were my values here? So P is the 0.7, which I was interested to find out. N is the 4, and my R is the 2. So when I go on the table, the probability table, my final answer needs to be add up. So it will be 0.008 plus these values are coming from the table, plus 0.076 plus 0.265. I add them all and I find out the answer 0.349. This is your answer here. And if you are using the CDF table, you will find out this direct answer from there, just I showed you. You just need a little bit practice and then you can be okay with that. Okay. Now folks, we will do one example here. I'm going on the next slide. Okay. The probability that a patient recovers from The probability that a patient recovers from COVID-19 is 0.4. This is not the actual probability, it's just to make an example. If 15 people are known to have caught with COVID-19, for example, we need to find out what is the probability that, so the first objective here is exactly 5 survive. The second part is at least 10 survive. And the third is from 3 to 8 survive. Okay, so what is the question now? The probability that a patient recovers from COVID-19 is 0.4. If 15 people are known to have caught with COVID-19, what is the probability that exactly 5 survive, at least 10 survive? And the third objective is from 3 to 8 survive. Now here you can see that we have two things here in the question. One is called either they can be recovered, or they can be not recovered. So this is what is indicating that this question is related to the Bernoulli trial or the binomial distribution. Okay, I'm going on the next slide. Before I'm going on the next slide, I just need to point out something here. So in this question particularly, what is my p-value here? My p-value is 0.4. My n value is 15, and my x value is based on the statement, which in part 1a is 5. So probability, I know that this is 0.4%, and there are 15 people involved. And for the part 1, these are the 5 survivors only. Now I'm going to the next slide. So for the part A, when x is equals to 5, exactly 5 survive. So in that case, you will have the probability that x is equals to 5, which is equals to b of 5, 15. It's the same formula that we were discussing before. And you get your 15, 5, 0.4 power 5, and 1 minus 0.4. It will be 15 minus 5 according to the formula. Okay, and then you find out your answer. I do not calculate that, so you can just figure out. Now this is when you have exactly 5 people. Now in the part B, he was asking us at least 10 survive. So for that one, we know for at least 10 survive. So this means to say your x value should be greater than or equal to 10. So this is also the same as I write it down as b of x is greater than equal to 10, comma 15, and 0.4. Okay. Now, there are two ways to solve this. One is that we start from 10 and go up to 15, which is 15 is the maximum. So how we do that? It's a B, 10, 15, 0.4 plus B of 11, 15, 0.4 and plus up to so on. You just keep working until you find out your B of 15, 15,4. Okay. So again, you just apply this formula here one by one on these separate terms and you find out your answer. So this is the one way to solve this kind of problem. Now there is another way. So I didn't find out the answer, so you can find out. So now the another way is that I'm going on the next slide now, please. Another way is that you use the complement function. Use the complement function which we have studied before. How we do that? We are interested to find out Px will be greater than equals to 10. So that is the same as I find out 1 minus probability of x less than 10. Or I can say that this will be 1 minus probability of x less than equals to 9. And this term I can find out using this formula. This is the Bx 15,04, whereas the x value should be from 0 to 9. That's what is the cumulative distribution function. Okay, cumulative distribution. Now this one you can use the table in order to find out the answer of this thing. So I'm just writing the answer for here. So my p-value is 0.4. I'm interested for n is equal to 15. My r value or x value is the 9. When I look on the table for the cumulative distribution, the answer comes out to be 0.9662. This is from table, okay? When you will watch this lecture, you can just pause the video and see from the graph, you will get this answer there. Now this is not the answer because I'm interested for this value here. So what that will be? P of x greater than equal to 10. That should be equal to, I should subtract 1 from this as we define here. Okay. This answer, it belongs to this. So this is 1 minus 0.9662. The answer turns out to be x is greater than equal to 10, which is equals to 0.0338. Okay. Now I'm going on the next slide. Now for the part 3, for the third part, no, let's go. This part C, he's asking us to find from 3 to 8 survivors. So for the part C, what will be my probability here? I'm interested to find out the probability when x is greater than equals to 3 and it is less than equal to 8. Now this formula will be summation of b of x 15, 0.4. Now I know that I need to find between 3 and 8. So for your summation, it should be n is equal to 3 to 8. Now we just expand this formula, which is the b of 3, 15.4. What I need to do, I need to apply this formula starting from 3 up to 8. Okay, plus the b of 4, 15, 0.4 plus up to so on. This will keep going until you find out your last term should be b of 8, 15 and 0.4. This is the comma. Okay, you just find out these term and you solve it and you find your final answer. Now this is one way. Another way could be, I need to use the next slide, please. Okay. Now the another way we could be, if I find out my b of x of 15.04 from n 0 to 8, and I subtract my b of x of 15.04 from n is equal to 0 to 2, this will be the same as I'm finding the range from 3 to 8. Okay, so this thing is the same as we are interested to find out previously. It is the b of x greater than equal to 3 and less than equal to 8. Okay. Now this is why I'm doing this. It is more easier to calculate. Now this term, basically the first one is the f of 8 and the second term is the f of 2. Now I go back to my cumulative tables or the probability tables. I find out that now my p is 0.4, my n value here is 15 and my r value here is 8. So from the table I find out my probability value, which is 0.905. These are from the table. Again, when you are watching this lecture in the repeat, you can pause the video and find out these values yourself. Now for this second part, I have my probability, which is 0.4. I have my n value, which is 15, and r value is the 2. Again, from the tables, I find out my probability value, which is the 0.0271. This is coming from the tables. You can use either of the table. You don't have to use both of them. But you need to make sure you're using the right table. Either it is a cumulative, then you don't need to add them. If you are using the probabilities table, then you need to sum up in order to get the cumulative number. So I have this value, I have this value, I just need to subtract them. So coming back to this one here, my p of x greater than equals to 3 or less than equal to 8 will be equals to my this term, which is 0.905, and I subtract it from this term, which is 0.0271, and your answer turns out to be 0.8779. That's your answer. Okay, this is how you use your binomial distributions. Folks, when you work at home, you will go to the page, just for your practice, on page 72 of your textbook, Douglas and George. You need to go on example from 16 to 19 from your textbook, and there will be some unsolved problems. You need to solve from 56 to 65 and problem 67 as well. Okay, Just do these and this will give you some problems to practice at home. And if you have any question, you can ask me. These problems, they are on page 77. Okay, I'm going to stop it here, and if you have any questions, I will be more than welcome to take those. Folks, do you have any question? Where we okay, Don is asking where can we find the tables? Don, I will provide this table with the lectures on D2L. The time I will upload this lecture, you will see both of these table over there. Okay. Is there any more question, folks? Now, I receive a question from Sean Adams. I think he is in the class at the moment. It was a very great question he asked me on the email. So I just want to share its answer with you as well. So he was asking me how much deep we should revise for the integration. So my answer to that question is you just need to know at least the integration by parts. So you need to know at least, you need to revise. I thank you, Sean, for asking me this question. So you need to revise the integration by parts, all the rules for this. By that I mean to say, for example, x is being multiplied by e of x. How do you take this integral? So you need to look back and refresh your work on this. And the second important component is how do you apply the limits on the integration? Limits of integration. So these two things you need to revise and brush up. Okay. Now I will suggest to every one of you, just develop your own formula book. Wherever the formula you see in the problems or the examples or the problems I do in the class, just write down in the separate notebook. So that will be your formula book by the end of this course, which will help you for sure. Folks, is there any more question? Okay, now I need to make a few announcements. I will set up your Dropbox for your project outline. I don't need your complete project now, but just the project outline as we decided about the deadline. And I will also provide you your very first assignment that you need to work on, maybe today or tomorrow morning for sure. Folks, is there any more questions you have? Okay, so I will let you go now and just work on those examples and the problems. Go through the lecture first. Just try to go through the tables. I will upload them as soon as I upload this video today. And if you have any questions, you are more than welcome to send me email. Okay. Okay, Usman is asking, can you please give some example regarding the project titles? It depends on your field of studies actually. You can have any project. I just want to make sure you use the concepts of this course and apply on your field of studies. It could be related to any field, electrical engineering, mechanical engineering, or chemical engineering. So for example, you can perform let's say the Monte Carlo simulation for environmental studies. One of the students asked me on the email and I responded him with that. So you can perform the Monte Carlo simulation of environmental pollutions. Okay, folks, is there any more question for me? So Sadiq is asking, most of the people are not active on D2L discussion. How can we form the groups? Well, my first preference will be you make a group. If not, you can have an individual project on your own. Just take an example from your field of studies. I believe all of you are in graduate studies, and you have your engineering degree or engineering background, or maybe at least a bachelor degree. Take any problem and apply the concept on your own. You don't have to form the group. If you're not able to find anyone in the group, that's fine. Just do it on your own. You can have your example. You can take example from your undergraduate studies or from your professional life even, and apply the concept of this course on that example to answer some of the questions. Is there any more question for me, folks? Okay, so I will set up the Dropbox for your project outline submission, and I will give you your very first assignment. I don't like to provide the assignment at the beginning of the semester because I know you guys are busy with some other things, and you know, I just want you to get relaxed and come into the course completely, and then we can have a discussion about your assignments and things. So you will have your first assignment available. If you have any questions regarding so far, you can discuss with me on email, or just drop me an email. If something is need to be discussed, we can have a meeting set up for that. Okay, is there any more question, folks? Okay, good. Thank you so much, guys, and see you on Thursday. Bye bye.